Peripheral devices provide the means of communication between the computer and other machines, and between the computer and the people who operate it. Some peripheral devices input information to the mainframe, others output information from the mainframe, and still other peripherals store information for later use by the processor. Some peripheral devices can perform combinations of these operations. However, all these devices share the same basic structure, which is described in Lesson 1 of this program. Lesson 1 also discusses some terms that are used to categorize peripheral devices. Lesson 2 describes some devices that perform input and output operations between the computer mainframe and other machines. Lesson 3 discusses some peripheral devices that perform input and output operations between the computer mainframe and people. And Lesson 4 covers auxiliary storage devices that hold information for the processor to use at a later time. Now let's begin with the general organization of a peripheral device. In general, the structure of peripheral devices consists of three major parts. A medium, which physically holds the information. For example, paper tape and punched cards are media that hold information in the form of punched holes. The drive mechanism is the part of the peripheral device that physically moves the medium. For instance, in some devices that read paper tape, the drive mechanism moves the tape and tests for the presence of holes using mechanical sensors. The third part of a peripheral device is the circuit that moves data to and from the medium. For instance, the control circuits convert the information on a paper tape into electrical signals that are sent along a cable to the mainframe. As you will see, peripheral devices differ primarily in the choice of medium used. For example, in input devices, the drive mechanism moves the medium carrying the information into the device. And the control circuit translates the information into bits and sends it on to the mainframe. The flow of information in output devices is just the opposite. The control circuit begins an output operation by receiving information from the mainframe and writing it onto the medium. The drive mechanism then outputs the medium that carries the information. The medium is handled in still a different way in auxiliary storage devices. Here, the control circuit receives data from the mainframe and writes it onto the medium. At a later time, however, the control circuit reads the data from the medium and sends it back to the mainframe. The medium always stays in the device. Now that we have described the basic structure of peripheral devices, we'll discuss some terms that are used to categorize them. Sequential access and random access are terms that categorize peripherals by the method they use to move information onto and off of their medium. In a sequential access device, blocks of information are written onto the medium one word or byte at a time. Later, the information is read in the same order. On the other hand, random access devices can read or write information on the medium in any order. Therefore, random access devices are more versatile than sequential access devices. Another way to categorize peripherals is by their ability to operate independently from the computer mainframe. Devices that can operate independently, that is, without exchanging information or control signals with the mainframe, are said to be able to operate offline. However, when the processor needs the information, these devices must be connected to the computer. When the devices are exchanging information with the computer and are being controlled by the processor, they are said to be operating online. Some devices can only operate online. Now that we've discussed the general structure of peripheral devices, go to your workbook for review and exercises. Your workbook will tell you when to return to this program. Machine-oriented input and output devices are devices whose media hold information in forms that other devices can use. There are three basic categories of machine-oriented input and output devices. The largest category is offline storage devices. The media of offline storage devices can be removed from the machine, stored in cabinets, and put back into the machine at a later time. Another category is analog converters and controllers. These devices are electrically connected to machines that operate on analog signals. The third category, data communication units, includes devices that are connected electrically to other digital computers or their I/O devices. The last two categories are covered briefly in your workbook. This audiovisual lesson will focus on offline storage devices, the largest and most varied category. Offline storage devices differ primarily in the media that they use to hold the information. There are two basic materials that are used to hold information offline: paper and magnetic surfaces. Paper storage includes paper tape and cards. On these media, binary ones and zeros are represented by the presence or absence of holes in the paper. The output device that uses cards as a medium is called a card punch. In a card punch, the drive mechanism moves blank cards from a storage bin or hopper to an output bin or hopper through a punch station. At the punch station, the control circuit converts binary information received from the mainframe into signals that activate punches. Each time a binary 1 is to be output, a hole is punched according to a specified format. The absence of a hole represents a 0. The punched cards accumulate in an output bin. From the output bin, they're collected and stored for later use. When these cards are input to a computer, they're placed into the input bin of a card reader. The drive mechanism in the card reader transports the cards one by one and moves them through a read station, where the control circuit converts the punched code on the cards into the binary signals that are sent to the mainframe. Other input-output devices that use paper as a medium are called paper tape readers and punches. Paper tape readers and punches operate in a manner similar to card readers and punches. Paper tape is a long, narrow paper which is punched to represent ones and zeros. In a paper tape reader, the punch tape is moved past the read station, and the holes are converted to binary signals that are sent to the mainframe. Paper tape requires less storage space than cards because the holes are closer together. And paper tape is easier to handle because the data can't get out of order. On the other hand, card readers and punches can move information faster. Cards can also carry human-readable information. Cards can therefore be read, and substitutions made easily in a deck of cards. On paper tape, changes require punching a new tape. There's another material besides paper that is used to store information offline: the magnetic surface on tapes and disks. These magnetic surfaces also hold machine-readable information. In magnetic tapes, the medium is a plastic tape coated with a magnetic material called iron oxide. On this tape, information is held in separate narrow channels called tracks. Typically, the number of tracks on a tape ranges from 1 to 10. In tape devices, the drive mechanism moves the tape from beginning to end over small electromagnets called read-write heads. There is one read-write head for each track on the tape. Tape devices perform both input and output operations using these read-write heads. During output, the control circuit converts words of information into electrical signals that pass through the read heads and magnetize the surface of the tape. Then, after the drive mechanism rewinds the tape can be removed from the system and stored. Eventually, the information must be input, either to the same computer that output the information or to a different computer. At that time, the tape is placed on the drive mechanism of a tape unit. During input, the drive mechanism moves the tape over the read-write heads again. The control circuit receives information from the read-write heads, converts it to digital signals, and sends it to the mainframe. Magnetic tape units can input and output information much faster than paper tape and card devices. Large reels of magnetic tape can store more information in less space than any other storage medium. This makes them most convenient for moving or storing large amounts of information. Where smaller amounts of information are needed, tapes are often housed in cartridges or cassettes. These eliminate the need to thread tape through a machine from reel to reel. Now let's talk about discs, another type of magnetic input-output medium. Disc units, like tape units, perform both input and output operations. But in disc units, the drive mechanism spins the magnetic medium under an arm that holds the read-write heads. Disc units input and output information much faster than magnetic tape. But large tapes hold more information in less space than discs, even when the discs use multiple surfaces. Also, magnetic tapes are more standardized and can therefore be used to transport information between computers made by many different manufacturers. On the other hand, discs generally cannot be used for this purpose. Now, when the machine stops, go to your workbook for a discussion of the relative merits of the machine-oriented input-output devices we have discussed. The workbook will tell you when to return to this program. I/O devices that move information between the computer system and people are called terminals. The medium for these devices represents information in a form that people can understand, such as alphanumeric characters, pictures, and graphs. The most common people-oriented input device is a keyboard. In a keyboard device, the medium is a set of keys, similar to the keys on a typewriter. When a person hits a key on a keyboard device, the drive mechanism resets the key so that it can be hit again. And the control circuit converts the movement of the key into a binary representation of the character. This binary form is then sent to the mainframe for processing. The most common output device on which people receive the results of processing is a printer. The output medium of a printer is paper that holds printed information. The control circuit receives the binary information to be output from the processor and selects the letters that the printing head puts on the paper. The paper is moved by the drive mechanism, which also positions the printing head of the device. Often, manufacturers combine a keyboard and a printer into a single unit, called a teleprinter, that can then perform both input and output operations. To a user, teleprinters look and appear to operate very much like typewriters. However, the internal functioning of the teleprinter is governed by the individual devices inside the keyboard device and the printing device. When a teleprinter is used online, a person hits a key on the input device, the keyboard, and the character of information goes to the processor. Most of the time, the processor sends the same character back to the output device, the printer. This happens soon after the key is hit, so that the operator feels that the keyboard has made the printer print. To perform this interaction, teleprinters are designed to operate at human speeds, that is, very slowly compared to the speed of the processor. Therefore, it's often more efficient for people to work offline at teleprinters or other terminals designed to operate without constant computer control. When these terminals are operating offline, the input device can send information directly to the output device without using the processor. Typically, these people-oriented terminals also include machine-oriented I/O devices, such as paper tape readers and punches, cassette units, or floppy disk units. Therefore, having offline operations, people can key information directly onto the machine-oriented medium where it's stored for later use. Then, when the terminal is switched online, the stored information can be transferred to the mainframe. These transfers occur at computer speed, thus using the processor more efficiently. Another way to use the processor efficiently is to use a high-speed output device. High-speed printers output large quantities of information that people can read offline, away from the computer and the terminal. Unlike the printing mechanisms in terminals, line printer drive mechanisms print entire lines, one line at a time, much faster than a person can read. Another people-oriented output device is a display, which has a television-like screen as its output medium. The drive mechanism in a display directs an electron beam that illuminates selected areas of the screen. Some displays can output only characters, while others can also output graphs and pictures. When a display is used in place of a printer as the output device of a terminal, the unit is called a display terminal. Display terminals are faster, more reliable, and do not produce the mechanical noise and vibration that make teleprinters unwelcome in an office environment. However, the output of displays is not permanent. As new items are displayed, old text is forced off the top of the screen. This type of output is sometimes referred to as soft copy. The output of teleprinters is permanent and is called hard copy. When a permanent record of the terminal's output is required, teleprinters are used. Some display terminals have another interesting feature, an optional input device called a light pen. The input medium in a light pen is the light and dark areas on the display screen itself. The drive mechanism is the operator's hand that moves the pen-shaped electronic sensor that is capable of detecting light and dark areas on the screen. And the control circuit senses which parts of the screen are light or dark. The circuit converts this input to electrical signals, which are then sent to the computer mainframe. The combination of light pen and display is a graphic way for people to communicate with computers. This is a great advantage in applications where complex structures can be represented in pictures rather than described in many words. Now, when the machine stops, go to your workbook for review and exercises on people-oriented I/O devices.